We are still in Module 13. We are now doing Module 13C. So if you remember, we've been talking about graphing linear equations. And the word linear is Latin for the word line. So we've been graphing lines, and if you remember, there are how many types of lines? That's right, there's 3. There's horizontal, vertical, and diagonal. And what we saw in the last module is that every line has the concept of slope. So we're going to talk more in depth in this module, 13C, about what slope means and how it relates, again, to lines. So if you don't take a minute, please get out your class notes. All right. If we go to our notes, we start with the definition. So as you've heard me say before, slope means the incline or the steepness of a line. Okay, when we talk about slope, we talk about mountains and hills, skiing. We talk about slope when we talk about building a wheelchair ramp. You could talk about slope when you look at the roofs of houses that are triangular. The steepness of that line is called slope. It is a number. Slope is always a number. And as you've seen with graphing, we usually write it as a fraction. And it refers to how you move from point to point. So when you talk about slope, you're talking about the steepness or incline of the line, and you're talking about how you move from one point to the next point. And we saw when you graph lines, you always are moving the same amount. That's what the slope is. Now, what you may not realize is there's 3 different ways to find this number for slope. And that's what we're going to go over today, the 3 different ways to find the slope value. The first way in your notes says use the picture. And I'm a firm believer everything we do on paper can be done by looking at a picture. So let's go up to the whiteboard and take a look at this. All right, everybody, here's my example. I'm giving you A at -2, 4, and B at -1, 1. And those are ordered pairs, or points. And what we could do with points is we could plot them on graph paper. So we're going to get out our handy-dandy graph paper, and we're going to plot them. So if we plot -2, 4, what does that mean? When you plot a point, you always start at the origin. The -2 means to go to the left on the x-axis, and the 4 means to go up 4. And that point would be in quadrant 2. Now we're going to plot point B, which is -1, -1. So again, when you plot a point, you start at the origin. The x value is negative, that's why we move to the left. The y value is negative, that's why this time we move down. And now we're in quadrant 3. And yes, if you connected those 2 points, what type of line would you draw? Very good. You would make a diagonal line. Now, I didn't ask you for this question to graph the line. I asked you specifically to find the slope. So if you're asked to find the slope, the first thing you got to remember is slope is always an answer. That's a number. So what I'm asking you to do is not do any work. I'm asking you to look at the picture and find that number for slope. If you understand what the word means, you'll realize this is going to be very simple. Slope is the incline or steepness of this line. And if you could tell, this line is going down, and it's pretty steep. When you're going to use a picture to find slope, you're talking about movement from point to point. So guys and gals, we do not need to do any work. If you have your handy-dandy graph paper, and I ask you to find the slope, put your finger on one of the points. I'm going to start here. Explain to me how I would move to get from here to here. As you know, on this system, you can't count diagonally. You can only move from point A to point B by either going up or down or right or left. And that's how we're going to do this. I'm going to give you a perfect example of how I use slope in my everyday life. I live in South Bossier, Bipsy's in North Bossier. It would be great if I could drive diagonally to get to work, but I can't. If you know anything about Bossier, between South Bossier and North Bossier is Barksdale Air Force Base. And I'm a civilian, I can't go on the base. So I cannot drive to work diagonally. So for me to go to work, I have to go down Barksdale, up Airline. That's slope. It's explaining the movement. When you talk about the movement from point to point, you got to talk about being horizontal, left and right, and vertical, up and down. Now, we know what variable represents slope. M. And we've already heard the catchphrase. Slope is rise over run. So when you're explaining to me the movement from here to here, first you're going to describe the rising. Well, if I'm here, would I rise up? No. So I would rise down. So we're going to count. So if I'm here and I'm talking about how I'm going to move, I'm going to go 1, 2, 3, 4, 5. Don't count where you start. I'm here. As soon as I move my finger, I count. 1, 2, 3, 4, 5. But I didn't rise up. I rose down. So that means that 5 is going to be negative. That means I went down. Remember, the word rise means to go up, and the opposite of up is down. So we went down 5. Now I'm here. I'm still not where I want to be. I want to be here. So now I'm going to run. And running means move left and right. So from here, I'm going to run 1 to the right. So I'm going to put the number 1 because I had to move 1. And because I went to the right, that 1 is positive. That is how you get the slope using a picture. You pick a point and you explain the movement. It's always rise over run. So it's either up or down first and then right or left. Now, because this number is a fraction, they're not going to accept -5 or 1. They're going to ask you to reduce it. So we would say the slope is -5 divided by 1 is -5. Now, it doesn't matter which point you use to explain the slope. Okay? Here's Bipsy, and I just went home to South Bossier. I went down 5 to the right 1. In the morning when I wake up, I'm in South Bossier, I got to get to Bipsy. Explain to me my movement. So if I look here, if I'm here and I want to get here, now I'm going to rise up 1, 2, 3, 4, 5. So now I'm going up 5, which means the 5 would be positive. So here I am, and I'm going up 1, 2, 3, 4, 5, but I'm not there yet. To get to Bipsy, I'm going to have to go to the left 1 place. Going to the left would make the 1 negative. Now somebody's going to say, well, that's not the same result. Yes, it is. 5 divided by -1 is still -5. So the moral of the story is, it doesn't matter which point you start with. If I ask for the slope, I'm asking you to explain me the movement from one point to the other. No matter which point you start with, we're going to arrive at the same slope value. So far, so good? All right, let's go back to the notes. So now that we understand how to find the slope using the picture, what happens if you don't have your handy-dandy graph paper with you? Well, mathematicians said, you know what? Everything that can be done looking at a picture can be done by doing paperwork. So if we look at our next slide, it says the second way to find the number for slope is using a formula. And I know I put the big M word up there that you have to memorize it. But sweeties, you already have it memorized. I know that looks confusing. Y equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You already have it memorized. Let's go back to the board and let's talk about that formula. Okay, so suppose I want you to take these same 2 points and I want you to find the slope, the movement of the line, but you don't have your picture to draw. We're saying now you can use this formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I know you're saying, oh my, I got to memorize that. You've got that memorized. If you know slope is rise over run, you know this formula. Because think about it. What does rise mean again? It means to go up or down. If you go back to the picture, which axis goes up or down? The y-axis. So that's why in the slope formula, the y's are in the numerator, because rise is in the numerator, going up and down. Running means go right and left. So if you look at your graph paper, which axis goes right and left? It's the x-axis. So the x's go in the denominator. Now, don't get caught up on these itty-bitty numbers. Those are subscripts. They're there because we cannot write the formula y minus y. Because if you wrote the formula y minus y, that would cancel out and leave you no formula. So to distinguish that there's two y values we're going to need and two x values we're going to need, we put the subscripts. What's important to note is this does not mean second y minus first y. It doesn't matter which order you subtract the y's. We just saw that with the picture. Did it matter if I explained the slope from here to here or here to here? No. We both got the same result. So I'm telling you right now, this does not mean second y minus first y. It just means take a y value, subtract the other y value. The most important thing about the formula is to understand the two values are connected by subtraction. The two values are connected by subtraction. So what we're going to do is we're going to take this same point, pretend we don't have the picture, and we're going to do the formula. So what I do to help myself out is I label x, y, x, y, just so I know who's my x and who's my y. The direction said find the slope. So I'm not drawing a picture now. I'm going to use this formula. It says take a y, subtract a y. So I do in order. Here's my first y, 4. I write subtract, and my other y is -1. Now I do the same thing with the x's. I'm just consistent. I go in the same order. If I did this y first, then I'm going to do this x first. So the first x is -2. I'm going to put what operation? Subtraction. And then my other x is -1. So that's all it is. It's a simple substitution. Now what happens is we know two negatives side by side multiply to make a positive. Subtract a negative means to add the opposite. Subtract a negative means to add the opposite. And if you look, 4 plus +1 is 5. -2 plus +1 is -1. And if we reduce that, we divide it, we get -5. Isn't that the same slope we got when we looked at the picture? Yeah, it is. So what I want you all to do is make a connection. If you're not told which way to find the slope, you have a choice to make. If you're a visual learner like I was, I would plot the points and count the rise and the run. If you like to do something on paper, then yes, take the 2 points, substitute them in the formula, get the result. It doesn't matter. They both do the same job. Okay, let's try another example. Okay, so in your notes, there's this next set of points. It says find the slope using the formula. So what I would do is I'd label x, y, x, y. Okay? I say slope is. What goes first? The y values. So the first y value is 3 minus, always put a subtraction, the second y value is 3. Now I'm going to be consistent and do the same thing with my x values. The first x value is -2. Subtract, the second x value is -7. In the numerator, 3 minus 3 is 0. In the denominator, 2 negatives side by side make a positive. -2 plus +7 is 5. But you wouldn't leave that because 0 divided among 5 people is 0. That says the slope is 0. Now what does it mean if the slope is 0? Because we talked about slope being the incline or steepness of the line. If you look back here at the first example, the slope was -5, where it makes sense. If you look at the picture, the line is going diagonally down. And if the slope is negative, we discussed that before, the line should go down. If this slope was positive, then the diagonal line should go up. But what happens if the slope is 0? Would the line go up? No, because that would be a diagonal line. Would the line go down? No, that would be a diagonal line. So we discussed this. What line stays steady? Whose slope is 0? Well, if you look at the picture and plot those points, -2, 3, -7, 3. If you connect them, they make what type of line? Very good. They make a horizontal line. And that's what it means if the slope is 0. It means the line is staying steady. It's not going up, it's not going down. If you had explained the movement from here to here, you would say, I don't go up, I don't go down. So my rise must be 0, but I'm running 1, 2, 3, 4, 5 to the right. 0 over 5 is 5. If I did it this way, if I was here, I would say to get to this point, I'm not going up, I'm not going down. So my rise is 0, but I'm going 1, 2, 3, 4, 5 to the left. I'd have a negative 5, and 0 divided by negative 5 would still be 0. So your answer by using the formula should make sense when you draw the line. Okay, let's try one more. Here are my 2 points. I have an x and a y and an x and a y. And the directions say find the slope. So again, if I use the formula, slope equals, in the numerator go the y values. My first y is 4. I put subtraction always, and then my other y is 8. Now I'm going to do my x values. My first x is negative 2. I'm going to put subtraction. My other x is negative 2. 4 minus 8 is negative 4. In the denominator, these two negatives make a positive. Negative 2 plus positive 2 is 0. Now, you can't leave that. It's a fraction. Fractions mean to do division. We should know our arithmetic skills. What is negative 4 divided by 0? Think about it, sweeties. If I lost $4 and I said divide that into 0 groups, could you do it? No. We've had a long conversation about this before. You can never divide by 0. Therefore, we call this undefined. Now, what that means is the line doesn't have a positive slope, it doesn't have a negative slope, and the slope is not 0. It's not staying steady. So look what I just demonstrated. If the slope was a positive number, we would have a diagonal line going up. If the slope was a negative number, we'd have a diagonal line going down. We just saw if the slope is 0, the line would stay steady, horizontal. What line's missing? Very good. A vertical line. Vertical lines you cannot ski down. Think about that in real life. If you were going to the top of a mountain and I asked you to ski, you would not ski vertically. You would kill yourself. So when you get a slope that's undefined, that doesn't exist, it means we would have a vertical line. Now to prove that to you, I'm going to draw the picture. If I plot negative 2, 4, that'll be there. And if I plot negative 2, 8, that'll be there. And sure enough, I can connect them, they would make a vertical line. And if I said explain the movement from here to here, you would say, well, my rise is down 1, 2, 3, 4, and I'm not running right or left because I'm there. So my run is 0. And that means a value of undefined. There is no number in our number system. If I did it this way, if I said explain the movement from here to here, my rise would be up 1, 2, 3, 4, so my 4 would be positive. But again, I don't need to run right or left, so my run would be 0. 4 divided by 0 is undefined. So what you need to learn is some concepts. Slope is always a number. Slope directly relates to what type of line would have been drawn. Even if you don't draw the picture, you should understand slope could be a positive number, that would be a diagonal line going up. Slope could be a negative number, a diagonal line going down. Slope could be 0, which means I'm staying steady. That's a horizontal line. But if I do my slope and I get undefined, that has to be a vertical line. Vertical lines do not have a number to describe their slope. Okay? And think about it. In real life, you can't ski vertically. You can ski diagonally. Sure, you can go on top of the hill and go down. You could ski diagonally going up. If you've ever been to the ski slopes before, you would realize that to get on the top of the hill, like the bunny hill, you don't have a chairlift. You have to physically walk. And yes, you could ski horizontally. I believe that's an Olympic sport called cross-country skiing. But no way on earth can you ski vertically. So that is why when we do our slope formula, we can get the possibility of 4 things. A positive number, a negative number, 0, or undefined. And that directly relates to the picture. So now we've talked about the 2 ways to find slope. We have one more way. Let's go back to the notes.